We've talked about factored form, we've talked about standard form, and now we're going to talk about vertex form. Take a minute and think, why might we call this vertex form? We call it vertex form because just by looking at the quadratic, we are going to be able to figure out the vertex. So vertex form is y equals a times x minus h squared plus k. H and k are our vertex. So notice it says the opposite of h. So h, k, there's our vertex. We pull out the h value, we pull out the k value. Our axis of symmetry is h, because remember our vertex, our axis of symmetry intersects our vertex. The role of a is the same. And again, please notice that other than x and y, which represent just any point on our parabola, the only other variable that all three of our forms have in common is the a value. So again, each form gives us a little bit different information to start off with, but if we know the a value for one form, we know the a value for every form. Let's look at a couple of these. So we're going to just practice writing the equation first off. Well, here's my a value, and then remember it goes h and then k. It's alphabetical, right? Just like x comes before y, h comes before k. So when I'm writing my equation, my a value is 5, and then notice, again, it's a negative h. So I need the opposite of h is how I read this. I always say opposite of h in my head. The opposite of the h value of -1 is a positive 1. So this will be x plus 1 squared. And then k is just the positive k, or the regular k, so it'll be plus 4. Let's do one more. A equals 1, and then we have an h value of 2 and a k value of -3. So I could write 1, but I don't have to write 1. I want the opposite of positive 2, which is -2, and then -3. So notice the sign for h switches, because that's what the formula says. The sign for k stays the same because it says stay the same, right? A negative times a negative would make it positive. A negative times a positive would make it negative. But here a positive times anything is just going to stay whatever that sign was. Let's practice graphing some of these. So if we wanted to graph y equals 2 times the quantity of x minus 1 squared plus 3. Well, our a value is a positive 2, so we know this is going to open up, which means our vertex will be a minimum. And our vertex, well, here's my h value, here's my k. So this would be the point 1, 3. Notice, because I want the opposite. It's a -1, so the opposite of that is a positive 1. I'm going to graph that point, 1, 3, right here. Well, my axis of symmetry is where x equals 1, because again, I know that my axis of symmetry intersects my my vertex. Now my y-intercept, my equation doesn't tell me that. So I know that that's the point where x is 0, which means I can substitute 0 in for x. And then I'm just going to use my order of operations to evaluate this. I know that 1 squared is a positive 1, so then 2 plus 3 is 5. There's my y-intercept, the point 0, 5. And then I can mirror that to find another point, 2, 5. Let me put some of these in my table. My vertex was 1, 3, and then we used substitution to find the point 0, 5, and we mirrored that point to find 2, 5. We got 3 points, we just need one more. So I'm going to substitute 3 in because 3 is pretty close to my other values. When I substitute 3 in, I'll have 3 minus 1, which I know is 2. I encourage you to find shortcuts for writing your work if you can do part of it in your head. I know 2 squared is 4. So really I'm thinking, what's 2 times 4 plus 3? Well, 2 times 4 is 8 plus 3 is 11. Now 11's not going to fit on my graph, so I could either adjust my scale or I could just estimate. Since I've already graphed the other points, I'm just going to estimate. If this is 10, 11 will be just a little bit higher. And then I can mirror that. This is 2 away on the right, so I want to point 2 away on the left. That would be -1, 11. And remember, if we had substituted -1 in, we could have mirrored that and found the point 311. So it doesn't really matter what x value you pick. You just want to pick something that's going to fit on your graph or closely fit on your graph. My parabola looks a little silly, doesn't it? I should try making that look a little bit nicer. Make it look as nice as you can. There we go, that's better. Let's do one more. So y equals -1 times the quantity of x plus 5 squared plus 2. Well, a is -1, so this is going to open down, which means that our vertex would be a maximum. Here's my h value, here's my k, so the opposite of plus 5 is -5, and my k value is 2. Remember, the h value switches, the k value stays the same. My x value is -5 because whatever my vertex x is, that's my axis of symmetry. Okay, I'm going to put my -5, 2 in my table, and I'm going to graph that point real quick. -5, 2. I like to graph as I go. You can graph at the very end if you want. Just personal preference, doesn't really impact anything. And my y-intercept, I'm going to plug 0 in. Now, 0 is pretty far away from -5, so I don't think this point's going to fit on my graph, but we'll see what happens. We'll get a -1 times 0 plus 5 squared plus 2. So that'd be 5 squared is 25, so a -25 plus 2 is -23. There's my y-intercept. Now I could adjust my scale, but I'm actually just going to pick a couple different points that are closer to -5 so I can draw my parabola. I'm going to pick -4 and -3. So if I substitute -4 in, I'll get -1 times -4 plus 5 squared plus 2. Well, that would give me a 1 squared. -1 times 1 is -1. -1 plus 2 is +1. I know I'm going kind of fast on these operations, but you're familiar with your order of operations. I know that you can pause the video if you need and figure these out on your own. When I mirror -4, 1, I get the point -6, 1. All right, last but not least, if we substitute -3 in, here's my -3 plus 5 squared. -3 plus 5 is 2. 2 squared is 4. So then when I multiply that by a -1, I'm going to end up with -4 plus 2, which is, of course, -2. -3, -2 would be right here. And then when I mirror that, I find the point -7, -2. And there's our parabola. It's opening down just like we said it would. So that's your vertex form. Again, all three forms give you a little bit of different information to start off with. So all three forms, we graph them just a little bit differently. We still need the same information, how it opens, our vertex, our axis of symmetry, our y-intercept, right? At least 5 points to make our parabola. But how we find that information is different based on whatever form you start off with.